The entry point is the main method. Inside it, we first set up our word bank, an array of 7 words related to programming. The game will randomly select one of these each time it runs. We create a random object called rand, and then pick a word by generating a random index within the array bounds using rand.nextInt, words.length. So word now holds the secret word the player needs to guess. Alright, let's walk through this Hangman game step by step. The very first line import java.util** brings in several utility classes that we need: random for picking a random word, #set to keep track of letters the player has already tried, and scanner for reading keyboard input. Then we have a multi-line comment that describes what the program does. It's a console-based Hangman game where the player has 6 wrong guesses before losing. Finally, public class Hangman declares the class. Everything else lives inside this class, making the whole game self-contained in a single file. Next we prepare the game state. We create a character array progress the same length as the word, and fill it entirely with underscores. This will represent the player's current display, showing blanks for unguessed letters. Remaining attempt starts at 6, which is the number of wrong guesses allowed. We use a hash set called useLetters to store every letter the player has tried. Sets automatically prevent duplicates and allow fast lookup. A scanner lets us read input from the console, and a Boolean 1 initially set to false will track whether the player has guessed the entire word. After printing a welcome message, we enter the main game loop. The condition while remaining attempts 0 and 1 means we keep playing as long as the player still has attempts left and hasn't guessed the word. At the start of each round, we calculate how many mistakes have been made so far by subtracting remaining attempts from 6. Then we call getDrawingMistakes to print the corresponding ASCII art, so the player sees the gallows and Hangman figure progress as they make mistakes. Now we show the player the current state of the word. We loop through the progress array and print each character followed by a space, so it appears as something like empty spaces. Then we show the set of letters they've already guessed, useLetters, which is great for avoiding repeats. We also remind them how many attempts they have left, and prompt them to enter a letter. The user input is read as a whole line and converted to lowercase to make the game case insensitive. We then validate it. The length must be exactly 1, and that single character must be a letter. Character.iLetter checks that it's not a digit or symbol. If the input is invalid, we print an error and continue jumps back to the start of the loop, asking for another letter. If the letter is already in the useLetters set, we tell the player they've already tried it and loop again. This way we never process duplicate or invalid guesses. If the input passes all checks, we add the letter to the useLetters set so it can't be used again. We create a flag correct guess set to false, then loop through every character of the secret word. Whenever the current character matches the guessed letter, we reveal it by setting progress, i=letter, and flip the flag to true. If the letter doesn't appear at all, the flag stays false. After checking the whole word, if correct guess is still false, we decrement remaining attempts and tell the player they guessed wrong. If it's true, we compliment them. Then we check for a win. We compare the progress array, now with some letters revealed, to the character array version of the original word using arrays.equals. If they match, the player has guessed every letter, so we set 1 to true. This ends the loop. Once the loop exits, we show the final outcome. If 1 is true, we print the Hangman drawing that corresponds to the actual number of mistakes made, which is 6, remaining attempts, then show the fully revealed word and a congratulatory message. Otherwise, the player lost, so we print the complete Hangman drawing, 6 mistakes, and reveal what the secret word was. Finally, we close the scanner to release the system resource, a good practice in Java. The last piece of our class is the getDrawingHelper method. It's static because it doesn't depend on any instance variables, it just uses the mistakes parameter that tells it how many wrong guesses have occurred. The method uses a switch statement to return a different multi-line string for each number from 0 to 6. 0 mistakes shows an empty gallows. With each mistake, we add a body part, first the head O, then the torso, the left arm, the left leg, and finally the right leg. Case 6 is the complete Hangman. If an unexpected number is passed, we return an empty string as a fallback. This simple approach allows the game to visually track the player's progress in a very clear way. And that's the entire Hangman game. It's a compact, single-class Java program that demonstrates arrays, sets, loops, conditionals, input validation, and a bit of ASCII art, all while being a fun, interactive console game. Any questions about any particular part,